Hello and welcome to the AIM webinar series. Before we get started, there are a few housekeeping notes I'll be going over. To start, first is our policy, our antitrust policy, and that is that we conduct our operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. Next is our collaboration and work product policy. AIM's collaboration and work product policy states that committee meetings or webinars like today are held for the primary purpose of advancements in our industry, which necessarily involves development of work product intended solely for the public domain. AIM's developed this policy for the protection of its members who engage in this important collaborative effort. And just some additional housekeeping notes. Today's webinar is being recorded. As a registrant, you will be notified when the recording is available. We also will have a brief Q&A at the conclusion of the presentation. To take part in this, please submit questions via the Q&A option, which is located at the bottom of the application screen. I'm pleased today to be joined by Director of Ecartes Technology, Sharians Bengani. Today, he will be discussing their interesting case study on streamlining document custody with automation. Sharians, welcome and take it away.
Thank you, Mike. Can you hear me properly?
Yes.
Thanks for the introduction, Mike. I'm happy to be here. Welcome to all of the attendees who took out time from their busy days to attend this presentation. What I'm going to talk about today is a typical use case for passive RFID, wherein we've streamlined document custody for a client using automation. The technology that is used is RFID, and we'll talk about it further. So before I jump on to the solution, what Ecartes is and what Ecartes does. So the company was incorporated in 1995, but in the mid-2000s, it was pivoted as Ecartes Technology. At that time, the vision was to provide a one-stop solution for identification and tracking. The name Ecartes is, of course, derived from the word cards, or French for cards, which at that time was the one-stop solution for identification and tracking. We started with cards, but we've kept pace with the rapidly changing technology stack, and we've diversified into RFID and IoT solutions, intelligent security systems, and we are also involved in e-governance projects as well. We are a leading provider of automation and identity solutions now, specifically customized identity and automation solutions. I'll talk about more in a later slide. We're also manufacturers of high-performance tags, so we've done backward integration as well, where we produce some high-performance tags and readers at affordable costs. However, that doesn't mean that all the solutions we deploy only use our products. We're happy to use products from established OEMs or other brands if they are deemed a better fit for the solution or for the requirements of the customer. We're ISO certified. We have also developed the first made in India printer in a technology partnership with a Korean firm. And we were the first members of the RAIN RFID Alliance from India. Some articles by our senior management have also been published on RFID itself, have been published by the renowned Kiesing journal from Netherlands. So this is just a map of the presence that we have. The one that you see on the right is the presence of the company itself, Ecartes. We're available, or we have offices across India. The image on the left, other than the red mark in India, most of the others, in fact, all of the others are partners that we work with in other countries. So they're having local partners in various regions enables us to deliver solutions more effectively, efficiently, and be at a quick turnaround. In terms of value proposition, there are 6 pillars that we rely on for the value that we bring to the customer. Security is one of them. We adhere to the latest standards and protocols. Again, this will be mentioned when I talk about the solution. Accuracy, of course, we're providing automation solutions, so they need to be accurate. Otherwise, it's just a futile attempt. Our solutions are seamlessly integrable. We already perform integration with SAP, Oracle, Microsoft databases, ERPs, etc. for various customers. So our as it often happens, our solution is simply a middleware for the customer to enhance their existing systems. And it's completely modular in design. So you can pick and choose, you can scale up rapidly, you can start small. That's one of the benefits also of the technologies that we work with, RFID. But at the heart of our value proposition, the two main important pillars are cost effectiveness and customer satisfaction. We do understand that the idea behind automation is to improve efficiencies, which in effect results in cost savings. But we do not, our vision is, or our endeavor is to ensure that the customer doesn't have to spend a lot just to achieve that particular kind of efficiency and automation. And customer satisfaction is, of course, the biggest one, because we provide customized solutions. And if the customer is not satisfied with our solution, then it's absolutely futile. So we operate in 4 broad verticals: RFID, security and surveillance, card personalization, and e-governance services. On most occasions, they go hand in hand. But if you're interested in any of our other verticals, I'll be happy to take it offline, or you can reach out to me later. This is just a snapshot of some of our popular RFID-based solutions that we've already delivered or are actively rolled out to customers. In essence, they're all based on tracking and management. The picture at the center is the best representation, probably, because even though the basic premise for most of them is RFID, it's not limited to one technology. So depending on the customer's requirement, we deploy a mix using GPS, Bluetooth, NFC, RTLS, and active technologies. You'll see a mix in this particular case as well. So I'll jump straight into file and document tracking, which is the main agenda of this presentation. Next slide. So beginning with the challenge, right? The challenge, and that's how typically an Ecartes solution is rolled out. We first talk to the customer and understand the challenges that are facing them. And in this case, the challenge was that the customer provides an end-to-end document custody and safeguarding services to a lot of, to a big chunk of customers at their end. And they were faced with storage, tracking, and management of 10+ million files. So when we started, they already had 10 million files that they had to ensure were being tracked and managed appropriately. And this happened at a time when manpower was becoming scarce and expensive, when the pandemic hit us, and the customer realized that enough manpower was never going to be available for them to be managing this huge amount of files, even with barcode. So then even barcode-based management started to bring their operations to a standstill. So they wanted to achieve a level of automation that would allow them to scale operations with increased levels of efficiency, but at the same time maintain the required level of control in operations, right? To ensure that there's a predictable and acceptable level of service delivery that they are sure to their customers. And they also wanted the automation of data capture with required accuracy at various stages of the value chain. So when they're shelving the files, and they're taking out the files, and they're moving it around, all of those stages, they wanted a certain amount of accuracy to be available in the automation. In terms of the critical requirements, there were 3 that were listed down. The ability to locate files within the shelf to a level of 2 to 3 inches of accuracy. This was to be done using a handheld reader, because they wanted to search for files using a handheld device. They're metallic shelves, so it was impractical to be able to find another alternative. Locating the file anywhere in the facility within a specific zone. And the cost of their sensor device needed to be extremely low, because the volumes were 10 million plus, right? So we couldn't even consider active technology. It would just have blown the costs out of proportion. So this is the solution approach that was taken. The first step was a site analysis to understand what was being done at present, what was the situation currently, and then evaluating the requirements, etc., that they wanted. Coming back and then deciding on the technology options available. I kind of walked you through some pros and cons that we had already thought. Once the technology was finalized, then providing a solution design, doing a pilot or a POC. In fact, it also included a pre-POC, in all honesty. And then once that POC delivered or showcased the capabilities of the system, then rolling it out and leading to, and then measuring the results of what was delivered. So when we performed the site analysis, this is just a brief summary of, I mean, the site analysis was far more detailed, but just a brief summary was that the area under purview could be characterized into 5 sections. It's pretty straightforward summary. And there was a receiving section, there was a breakdown section, there was a review, audit, image processing, and long-term storage section. The breakdown section is where all associations were happening, including the associations of files to stacks and files to boxes, because they were using boxes and carts and trolleys to move these files. So those associations would also happen in the breakdown section. The facility layout was studied. Of course, it was visited, studied, and analyzed deeply. We can't share all the details here due to confidentiality reasons. Technology, I think I've already mentioned it before, but the technology selection, we finally decided on RAIN RFID or UHF RFID. There were significant reasons for choosing it. The cost of the sensor device needed to be low, which UHF provides. It provides multiple tag reading at a long distance without line of sight. There's a long tag life of 10 plus years. Fixed reader and antenna setup would enable automated directional movement detection. There are RTLS antennas available that could provide the accuracy or the location of a particular file with an accuracy of up to 1.5 feet. And tag costs I've already talked about. So looking at all of the requirements of the customer and the cost angle, RFID, RAIN RFID or UHF RFID ticked all the boxes. I think this is probably the next couple of slides are the most interesting ones, or the most relevant ones to this technology. So there were the solution components, right? What all components were used in this entire setup. So the first thing was the tags, obviously. So we chose standard, coated paper tags for the files because the cost needed to be kept within range, but they were printed and encoded with a barcode as well. And they were encoded using a RAIN CIN. For all those who want to know more about it, I'll be happy to explain later in the Q&A. But the RAIN CIN allowed us to follow protocols, adhere to protocols while using a proprietary numbering system and reduce the chances of acid rain or duplicate tags across the globe. Then there were fixed readers and antenna setup for the directional movement at various checkpoints. They had around 10 to 12 checkpoints within the premises. There were desktop readers which were used for mapping the files to the tags, handheld terminals to perform on-demand scanning, shelving, associations, etc. The ceiling RTLS readers would give us the location of a file when it was moving around in the premises. And then there was the integrated middleware, which would take the data from all of these components and feed into the IoT gateway that was being provided by a global system integrator, who was also the prime contractor, so that data could be used in their existing system. So we didn't completely overhaul the existing end user interface or the end user system. That stayed the same. The idea was to make the existing system more efficient by using RFID and integrating RFID into it. So the various features that we used and the components that were probably used for it. Of course, what is missing here is probably that the middleware that's integrated into the gateway is applicable in all of these features. That's what connects these hardware elements to the final software. So the desktop reader would of course be used for file registration. The shelves were, I think I missed mentioning on the previous slide that we used some on-metal shelf tags for the shelves, and they were registered at the shelf itself. So a tag was applied, the handheld reader and the application helped to register the location of the shelf tag of the shelf onto the system. Boxes, totes, and carts were also registered as and when they were present. And then once all of this tagging was done, this association got done, then we could do all of the tracking and the management. So put away and retrieval of files. So they have files that come in from their customers and they need to be shelved. So whenever a file or a set of files was to be assigned to a shelf, the handheld application was used to put away files to a shelf, to also retrieve files from a shelf. Before retrieving, we also had a file search mechanism. So if someone wanted to search for a file, they would know what the system would tell them that they have to go to a particular shelf, and then they could turn on that search feature, which would give them an audio visual indication based on how far they were away from the file. And this was done with a 2 to 3 inch accuracy by implementing SOPs and ensuring that the files are stacked correctly at all times, and having complex algorithms embedded in our application to achieve the desired output. I'll talk a little more about it in the next slide. This handle application is also used to associate and disassociate files from shelves. So when you're taking something out of a box or taking something out of a cart, you have to disassociate it from that particular movement vehicle. And then we have checkpoint tracking, like I mentioned. So fixed readers and antennas provided the movement or automated tracking, directional tracking, whenever files were carried in a box, past a checkpoint, or taken from one side to the other. That helped us capture that information. And then RTLS sealing readers were deployed across the premises, so that anytime the files were not in any of the other shelves or passing through a checkpoint, we would know where exactly in the premises they were. These are just some handheld snapshots. You can see that the shelf registration, you enter the room number, the row number, the columns, the shelf number, and the description. When you want to retrieve a file. So this snapshot is to give you an idea that the distance at which they wanted a 2 to 3 inch accuracy. So the image that you see on the right, 74%, the color turns green only when you're within 2 to 3 inches of a file. Before that, it's yellow, and before that, it's red, and before that, there's nothing at all. It'll always show you a file detected, but they wanted that green color to come up only when they were within 2 to 3 inches of the file. This is a little more visual description of the checkpoint scenarios, because all of the checkpoints were also not straightforward. They weren't just doorways straight away. There were entry and exit, larger entry and exit checkpoints where we had to deploy 1 reader and 4 antennas to ensure that we covered the entire passage. There were staircase areas which had to be tracked when we had to deploy 1 reader and 2 antennas, because the staircase was fairly narrow, and I mean one antenna on either side sufficed. And then there were they also wanted to track movement in and out of elevators, wherein again the proposed idea was to have 1 reader and 2 antennas set up just outside of the elevator. So anytime something went in or came out of the elevator, we knew that it had entered that particular floor. Yeah, this is the most interesting one, because I'm sure most of you are fairly well versed with RFID solutions and how they work, and I'm sure a lot of you would probably already have been having that question of how did you achieve that 2.3 inch accuracy, because RFID or passive RFID, UHF RFID is difficult to play around with that in that sense. And there are so many scenarios, exceptional user scenarios that could come up. Of course, it was not feasible to list all of them down, but I've mentioned some 4 of the more prominent ones that needed a lot of workaround from our end. So the first one is the 2 to 3 inch of accuracy. The location of the tag on the, so we had to implement a lot of workarounds and SOPs to ensure that these desired outputs could be achieved. So the location of the tag on the file is fixed. The tag is also a specially designed tag, wherein the antenna is not in the middle of the tag, but it's towards one corner. So the antenna is always towards the person who's trying to approach the file. It's always facing outward. There was an SAP enforced to store the files with the open side facing forward. The height of all tags was ensured to be the same whenever they're stacked, and the reading was supposed to be from front on, and a complex mathematical model on the RSSI signal with some other algorithms was established to achieve the 2 to 3 inch accuracy. There were other cases also where we already intimated the customer that not all files would probably be read. So if they were carrying 200 files densely packed in a box and expecting that all of them would be read when transporting, there was always a chance that we would have missed some. But the file to box mapping enabled us to track the boxes when they were being moved instead of the files. And since all the files that were attributable to that box, even if some of the files were missed in that transition, the box was still being tracked, and we knew that that file was, because that file was inside that box, it would have happened. In case one of or few of the files were taken out by someone, their locations would be captured by the ceiling reader. So then that information would be fed into the gateway saying that these files were associated to a particular box, but now we can see them in this region. So they're not inside that box because the box is somewhere else, and they've probably been disassociated from the box. If someone takes out a file from a shelf, takes it to their desk without following the process, again, a similar fail-safe was implemented, because even if they took it really close to their body and it somehow evaded all of the tracking points, there would be a ceiling reader somewhere around the desk, because these ceiling readers were established or installed all across the premises, that would capture the location of the file once it reached the desk, and then send it out to the gateway that this file is currently in this position. And then finally, when nothing would be, this was a fail-safe that was taken or implemented considering the pandemic and the lockdowns that ensued with it, that in case something got shut and even based on the festivals that happened, right, 4 or 5 days, nothing is getting read. It could have been two cases, right? One is that our system is down. The second is that there's just not been any work done. So to mitigate that, we had health packets sent every hour to the gateway, so that at all times we know that yes, the systems are working. It's just that maybe it's a holiday or work has been stopped. That's why we're not getting any reads. And if the system is down at any time, the health packet intimates that to the gateway, so that can be fixed immediately. This is the middleware features. So the middleware is what feeds into the IoT gateway provided by leading global system integrator. The system integrator is actually the prime contractor to the end customer. We don't work directly with the bank. The integrator is the one who's integrating our prime contractor, and we integrate our solution to their gateway. So health packets were being sent, huge amounts of data handling capacity. If network is down, I think pretty standard features, right? It stores the data locally and starts sending it back once the network is running. The format being used is JSON to an MQTT broker. They're used for connecting to Wi-Fi. They're using ETLS or Enterprise 3 security levels. And yeah, it's making a sequential queue to send the data to the MQTT broker. So finally, the results that we expect or estimate will happen. They'll have end-to-end document traceability. There'll be instant alerts across document vaults. We expect a 2 to 3 increase in revenues because the solution is scalable. Their efficiencies would have increased. Up to 50% reduction in document retrieval time, which is a significant cost saving, plus 30% lower costs overall through RFID-led automation. Production rate is expected to increase by 4x, and then the expectation is that this is very close to verification right now, but a minimum of 80% straight through processing across all document types, improved audit trails that reduce document losses or help to prevent document losses, and seamless integration with further downstream apps to have more detailed analytics and probably even feed into an AI system. What next? We are in discussions to expand to other locations for the same customer. And then more importantly, not just for file tracking, right? We believe that this particular use case, just the nuances it had and the way they were tackled and the results that are being seen or will be verified soon. It can solve similar complex problems across multiple industries like banking, insurance, medical industry, records, etc. It can also be integrated with tracking solutions like a state-of-the-art warehouse management system, which is also under discussion. And we're also exploring the possibilities of leveraging AI, ML, and even robotics. We have state-of-the-art robots now from some other partners. Because of all the data and the automation available, they can, the need for or necessity for a human to be present can be even further reduced. So thanks. That's all I had today. I know it's probably a lot for such a huge and complicated case study, but given the time at hand, that's all I have. I'm happy to answer questions or clarifications, queries. We're also looking out for partners pretty much across the globe. Do reach out to us if you're interested in joining hands with Ecartes.
Thank you, Shrins. Really appreciate the case study, and we'll get into questions. If you still have any questions, you can send them to us via the Q&A option. It should be located at the bottom of the application screen, and I will share the Ecartes contact information again before we go here. So to start, was there any customization done to the hardware pieces itself, like the readers or tags?
So I already mentioned about the tag, right? So the tag, in terms of hardware customization, the tag itself is a slightly customized version. I wouldn't say it's a radical innovation, but it's just a small, innovation that we've done to ensure that we got the output that was required, or we were able to deliver the output that was a critical requirement for the customer. In terms of the reader itself as well, the fixed readers, not on the hardware, but the firmware was customized to connect to the MQTT broker, and then also to be able to send held packets directly. And it's what is notable here is that the fixed reader has that firmware and application installed within the reader. So it's not like it's connecting to a server and the server communicates. It simply connects directly to the gateway and sends held packets directly to the gateway.
Thank you. And we have two questions that I think are kind of similar, so I'll just put them together. And that is, what is the RAIN CIN and its purpose? And then they just someone wanted you to explain further how you what you mean by pre-programming the tags.
Okay, so I'll talk about the RAIN CIN first. The RAIN CIN, and I see a lot of guys from our application ID team in the RAIN Alliance are also present here. But the RAIN CIN is essentially an identification number that allows you to follow protocol, a registered protocol for encoding tags. So it's not like you're just arbitrarily encoding tags using your own random number. And at the same time use your proprietary numbering system. So the number that we saw on there, right, A0001, that was there on the image. It's a number that we've decided for our file tracking system. It could so easily be that someone else also decides the same numbering system. And then if ever both of the tags happen to be in the same place, we wouldn't be able to differentiate between my tag and their tag. That's what is called as acid rain, or a duplicate tag. And the whole purpose of the RAIN CIN is to avoid such a kind of situation, especially when you're dealing with such a large volume of tags. So we have 13 million tags here. There's easily a chance that one of those numbers is the same as something someone else is probably also using for their file tracking system. We're using a simple F followed by a serialization. But because it has a RAIN CIN at the very beginning, that's encoded, and the RAIN CIN mandates what the PC word must contain and what your final EPC, the first 4 digits of your EPC look like. So that is one way that we identify that these tags are our tags. And even the entire reader setup, right, handheld, fixed, RTLS, they're all also looking out for the first 4 digits. So the moment none of those, the moment there's any tag that doesn't have the CIN encoded in it, the systems will disregard it in our case. So we ensure that we're only tracking our tags and not tracking other tags. The other advantage that this also brings is it brings in efficiency. We're already having 13 million tags to track. If there are more tags in the premises that we start reading, then our latency starts, further latency starts to kick in and our system becomes slower. And what is meant in terms of pre-encoded or pre-coded tags is that the customer is not encoding or printing the tags at their end. We are printing and encoding it and sending it out to the customer. So all that the customer needs to do is take it off, put it on a file and map it to the particular file. So it's just designed so that the customer, because they already have so much to do with the management of so many files. So it's designed to save time at their end, where we are pre-encoding and pre-printing the tags at our production facility before shipping them out.
Great. And how easily replicable is this solution?
I would say it's fairly easily replicable, because most of the features or the modules I talked about, right, would probably be present with other similar document management, or not even document management, even asset management or inventory management cases as well. We're talking about files here, but you could have other kind of assets that are stored in shelves or that are taken out or transported, etc. So I would say it's fairly easily replicable, not just for document tracking, but for other industries as well. Warehouse management is a very similar use case, where you stack assets and inventory on shelves, you take them out, and then you move them around the warehouse. So, of course, I do understand that it's not going to be a simple copy paste. You would have to customize and sort of tinker around with the solution to ensure that the fit is appropriate for the other customer. But the customization wouldn't be a lot in that case. In terms of the underlying technologies and modules, it should be fairly similar. The aesthetics can definitely always be changed.
Great. So going along with that, on one of your previous slides, you mentioned some potential other use cases for the technology. This person was wondering, they didn't see retail sector being looked at there. Would it be possible in retail? What are your thoughts
Absolutely.
on that?
And I know I missed out on that one. I was just thinking out myself as well, that we forgot to mention possible applications in retail. Retail is probably the closest one to this, because the volumes are similar. In retail, there are not a lot of other industries in which volumes are so huge. So retail has similar volumes, and the interference from water or metal that's typically a hindrance in deploying a UHF solution is also fairly low for retail use cases, right? I think apparel, even within retail, apparel or garments would probably be a great use case to replicate this at.
And what challenges did you encounter in reading dense stacks of files, or when tags got covered by human bodies or metals?
I think the challenges that we face in all installations, this was a huge one. So even with sometimes we do installations for small businesses where there are like 10,000 tags, and we face the challenges, those challenges with the same, with those small installations as well, because water and metal are a pain when you're working with UHF technology. They'll just throw off all kind of readings. And that's why I mentioned the workarounds, right? Because we anticipated that there would be cases where someone's covering the file tags or taking it close to the body, or we might not be able to read all of them because they're just so densely packed. We implemented fail-safe mechanisms or workarounds to ensure that we still had, we still were tracking all tags at all times. And this was possible actually only because we covered the entire premises. There are a lot of cases where the ceiling readers, right, because they're expensive, they're not deployed across entire premises. And if they weren't present, then some of these challenges might not have been mitigated. Mike, I'm also getting seeing three questions here. I don't know if they're coming directly to me, or you want me to take
there's some other questions there too. Yeah.
Yeah, so I'll just quickly, there are a couple of ones which are similar. I'll take one from there. What's the difference between fixed reader and RTLS ceiling reader, and what's the accuracy reading level of these fixed reader and RTLS ceiling readers? So a fixed reader is simply a is a 4-port reader with 4 antennas attached to it that helps in tracking the directional movement of tags at various checkpoints. The RTLS ceiling readers are installed in the ceiling, and they provide the location at an accuracy of up to 1.5 feet of each tag that's within the reading range of that reader. So the ceiling reader is the ceiling reader is something that gives you the location of the tag at all times. The fixed reader only scans tags when they're passing through that premise. And then the accuracy level of these it's fairly high, but as I explained in the previous slides, there are occasions or situations in which we will not always be able to read all of the tags, and that's why we had workarounds implemented.
Great. So we do have a couple questions too about costs. You mentioned the tag costs are extremely low for high volumes, making it a significant factor in project feasibility. Could you provide some insights into the cost effectiveness of implementing RFID technology at such a scale?
So the costs will of course vary, and it's I don't think it would be right for me to share the costs over here, but do reach out. I think Mike will provide you the contact details that I have. Depending on whatever your requirement is or the volumes you're looking at, we can provide you a fairly low costs on tags. That's one of our competencies, and I'll be happy to discuss any possible solutions that anyone has or is wanting to implement.
Great. And the last question that I have here is basically what do you see as the future for document custody protection, especially with RFID and other AIDC type of technologies?
I think the future is really bright because I mean, based on the solution that we've just implemented, it's such a huge volume of files, and the results that we're seeing are really, really motivating and encouraging. And I think this is just the beginning. Like I mentioned, we're evaluating robotics to come in for further automation, and then trying to understand, because with the tracking of so many files, this is such a huge chunk of data set that we have, which makes it ideal for further analytics through maybe AI or ML, and trying to understand how the files are moving, how can they be moved better, is the shelving techniques correct, because all of those are currently designed as per the data that's available. But with the tracking data that we have, once it's once it's a little more settled, we can have so many more suggestions and recommendations on what could be done further to get even incremental efficiencies. And at some point, I think we should be even able to achieve 99.x% straight through processing very quickly. I see that happening maybe in a couple of years.
Great. Well, thank you for your time, your insights, and sharing this case study with us today. Greatly appreciated.
Thank you. Thank you, Mike, for having us. And thank you to the AIM team for arranging for all of this. It was a pleasure.
And I'd also like to thank the audience for their active participation. If you do have some more questions, we do have contact information there on the screen right now. I will let everyone know when this recording is available. And again, thank you everyone for your time today, and hope you have a great rest of your day.
Thank you. Thank you, everyone.